All right, now we're going to take a look at OSI layers. OSI layers are important for a couple reasons. One, it's very useful, to have another mental model that we can use to understand troubleshooting issues, technical issues, configuration issues, those kinds of things. Two, OSI model questions will certainly show up on your final exam and any certification exam you take, even beyond just like the Network Plus or the Security Plus. If you're taking Linux certification exam, everything, OSI touches everything. And finally, it is exactly the kind of thing they like to ask you at job interviews. So a really firm understanding of the OSI layers. And when I say a firm understanding, I don't mean memorize the layers. You should memorize the layers in their order, but that's not what I mean when I say a firm understanding. I mean you really have to have a grasp of what problem each layer solves. Maybe not necessarily at the end of this, but by the end of this class, right? So we start with our base layer, which is the physical layer. I like to think about these layers as solving different problems, right? One of the problems I need to solve if I'm networking, if I'm trying to get two computers at a distance to talk to each other, is I have to send the information from here to there. So how do I solve that problem? That's what the physical layer solves. So if you're talking about things like Ethernet cables, right, you're talking about positive and negative voltages. If you're talking about things like Wi-Fi, you're talking about radio signals. If you're talking about fiber optic, you're talking about a thin piece of glass with light pulses. But somehow I need to physically send ones and zeros from here to there, right? That's what the physical layer deals with. All right, let's move that down a little bit. The next layer is the Datalink layer. So once I solve the problem of how do I send ones and zeros from here to there, how do I get multiple devices to share that particular method? Now nowadays we don't think of it as sharing because most of our devices have like an individual wire. So our computer has an individual wire to the switch. But that switch has multiple devices that are connected to it, which it then uploads to the next step, which might be a router. And then you have multiple channels that are all sharing that serial connection on the router. So we have to share whatever it is our physical media is. So that's the problem the Datalink layer solves. So the technologies that we're usually thinking about in the Datalink layer are like Ethernet or Wi-Fi, right? Those are Datalink layer technologies. We'll talk a lot more about those later on this semester. The next problem I need to solve, okay, so once I know how do we physically send the data, how do we share this media that we're using for physically sending data, how does the data find its way from here to there? That's the network layer, right? The network layer is how does the data find from here all the way to there? So that has to do with routing and switching, and in almost every case nowadays we're talking about internet protocol, IP. So if you talk about IP addresses, you're talking about things on the network layer. The next related problem that we need to solve is the transport layer, or is the problem with the transport layer. Once I know how the data can find its way across multiple networks from here to there, how do I get it there reliably? It's not as big an issue anymore because our networks are much more reliable. We have a much better understanding of how packets fail, and we've eliminated many of those problems. But certainly in the original days of networking, guaranteeing that your packet gets there, that it gets there correctly, and that it gets there in order was a really big deal. So transport's really important. Transport is directly related to the next layer, which is the session layer. So the session layer is concerned with, all right, once we can get it there reliably, how do we start a session and then end a session, right? What's the protocol for that? So if you think about picking up a phone and dialing a number and then saying hello, that starts a session. At the end, you both say goodbye and you hang up the phone. That ends the session. Similarly, when we have data traveling back and forth, if you're watching a movie, if you're downloading a file, there has to be some protocol for starting and ending that session. That's what this layer is concerned with. The next layer is concerned with how is the data presented. Now, this is an important thing to be mindful of. The presentation layer has nothing to do with how things are presented to you as the viewer, right? It's not when you look at a web browser, right? That's not the presentation layer. It's how the data is presented. How is it formatted? It's all ones and zeros that we have encoded to have some meaning. A really common example of this is ASCII. So if you look at an ASCII table, the letter lowercase a is all the way over here. In decimal, it is the value 97. In hexadecimal, it's the number 61. There's some binary equivalent for that. Yeah, there's some binary value for that. I'm not going to do the math right now, but that is the encoding of the lowercase a, right? The presentation layer is how do we on both ends agree, yes, this is what we're going to use to represent A, and this is what we're going to use for B. That's the problem that the presentation layer solves. And our final layer of importance is the application layer. And again, this still is not the application that you, the user, see. There's all kinds of applications that are using the network constantly that you don't see anything. This is what is the application protocol. HTTP has a protocol. Your browser, when you type in a web address and hit enter, formulates what's called a GET request, and it sends that to the server. The server responds with an OK text response. That's part of the application layer protocol so that your web browser and a web server can talk to each other. So each of these 7 layers is a problem that has to be solved for a network to function. And we're going to be going through each of these in a lot more detail throughout the rest of this semester.